Section 11.2, we're going to look at areas of trapezoids, rhombuses, and kites. So let's take a look. If you look at a trapezoid, you have two parallel bases right here. And you can also look at a perpendicular height. The thing is, if you look at area equals base times the height, your bases aren't the same. So we know we're not going to be able to use that idea. But if you take this trapezoid right here and you make a duplicate trapezoid, turn it and slide it together, now what you have is you actually have a parallelogram right here. And so your base of the parallelogram is actually your base 1 plus your base 2 combined. And your height is still the same in both. So what you have, since you're only looking at this half of it, is we can really look at it as the area is 1/2 of base 1 plus base 2, because that's your base, times your height. So that's one way to look at the area of a trapezoid and maybe help you remember it for the future. So that is the formula for area of a trapezoid. Area equals 1/2 the height times base 1 plus base 2, or you can put the height over here. Okay, another way to think about it is 1/2 base 1 plus base 2 is really the average of the bases. That's another way to kind of help you remember it. But remember, the bases are parallel and the height always connects the bases and is perpendicular. So something simple like this, we find the area of the trapezoid. These are our bases. We can see our height right here. So we can call one base 1 and one base 2, and that's our height. So our area is 1/2 8.9 plus 13.7 times the height. So that's all we have to do on this problem. And we multiply all those together. Our area is about 119.78 units squared. So let's let you find the area of this trapezoid. Keep in mind, this whole base, you're going to have to add those two numbers together. And our height right here, you're going to have to find. But I think you can do it. So I'd like you to try that one on your own and then check the notes to see if you got it right. We're going to move on to kites and rhombus. So if you look at a kite or a rhombus, we really don't have bases and heights in here. But what we can look at is we can look at this as being a diagonal. And we can look at this as being another diagonal. Okay, great, but how does that help us? Well, it turns out that if you actually take like this piece right here and you flip it around like this, and you take this piece right here and you flip it around and put it right here, now the new figure that you have is this. And that's a shape we recognize. That's just a rectangle. So we know our formula for if we did this figure right here as a rectangle would simply be area equals the base times the height. Well, what is our base? Our base is the same as diagonal 2, in this case, times our height, which if you look at this diagonal right here, it's only half of that diagonal. So our area is 1/2 diagonal 1 times diagonal 2. And there's other ways to think about this too. Instead of me just pulling the pieces to the side, you could actually also duplicate every piece rather than just sliding them over. And if we duplicate the other pieces here and here, now if we're finding the base and the height, we have to take half of it because we're only interested in half of what we have found the area for. So again, hopefully those things will help you remember the formulas, help you keep them in your memory. So find the area of the kite or the rhombus. And sorry, I forgot to mention that the rhombus and the kite have the same formula. So I'm going to let you do the first example. I'll go through the second one, and you can check back for to the notes for this first example. But let's look at what we have here. We have 4 congruent sides right here, so we know it's a rhombus. And remember, in a rhombus, the diagonals, it's a parallelogram, so the diagonals bisect each other. So now we have area is 1/2 diagonal 1 times diagonal 2. It doesn't matter which one you call diagonal 1 or 2. But now you're going to have one of the diagonals is 3 plus 3 or 6, and the other diagonal is 8 plus 8 or 16. So our area is 48 units squared. Again, try that other one on your own, and let's move on. Find the area of this figure. Now this is a kite because you can see we have consecutive sides congruent, 2 pairs. So the area is going to be 1/2 diagonal 1 times diagonal 2. Well, I have one of the diagonals right here. So 1/2, and when I add 24 and 15 together, that gives me 39. But I need to find diagonal 2. I don't know what diagonal 2 is, but what I do see is this is diagonal 2. And remember, in a kite, the diagonals are not only bisected for every parallelogram, but the diagonals are also perpendicular. So you have to remember all of your properties of quadrilaterals as you go through finding the areas. So I can find this piece right here, I'll call it x, using the Pythagorean theorem. So 24 squared plus x squared equals 25 squared. So now when I take 25 squared and subtract 24 squared, that gives me 49. So x is equal to 7. So this is 7 and this is 7, so this is 14. So now my area, if I take 14 times 39, and I like to just find that and divide it by 2, but you can multiply by 0.5 or the fraction 1/2 in parentheses. That gives me an area of 273 units squared. So now let's move on to doing some area of the shaded figures. So let's go ahead and try this one. So what do we have here? Well, we have this trapezoid right here, and then we're going to have to subtract from it this rhombus. So let's work on finding the area of the trapezoid, which, remember, that formula is 1/2 base 1 plus base 2 times the height. And then from that, I'm going to have to subtract the area of that rhombus. And that formula is 1/2 diagonal 1, which I can see is 10, and diagonal 2. Now notice that this is the mid segment, this piece right here. So again, we're always going back and using a lot of the stuff we've already learned. That is the mid segment. It's parallel to the third side. Remember, it's the average of the bases. So to find this other diagonal, I have to take 15 plus 11 divided by 2. And that is 36 divided by 2, so that gives me a diagonal of 18. Okay, so when I take 11 and 15, I get 26. Times 10 is 260. 260 divided by 2 gives us 130. And then from that, I'm going to subtract. 1/2 of 10 is 5, so I'm going to go 5 times 18, which gives me 90. So my area is equal to Did I do that wrong? I somehow did this wrong. 26, oh yeah, sorry. I was looking at my work and that didn't make sense. So actually this is 11 and 15 is 36. 10, 20, it's 26. So this should be, sorry, little mental math error, 13. So this has to be 13. And that changes that to 65. So now my area, my total area would be 65 units squared. Sorry about that. All right, so your turn. Well, actually, I'll go through one of these and then you try one. This one, you're going to find the value of x when you're given the area of that trapezoid. That's a simpler one. I'll have you try that by yourself on your own. Check the answer when you're done in the notes, but I'm going to move on to this one. So you might want to watch this one first, because this one's a little bit tougher. Same kind of idea, but we know the area for a trapezoid is 1/2 base 1 plus base 2 times the height. Again, it doesn't matter where you put the height. So I'm given the area is 288.96, and that is equal to 1/2 base 1, I'll call that 40.2, plus base 2, which I don't know, times the height, which is 9.6. So the first thing I'm going to do for this particular question is I am actually going to multiply the 1/2 and the 9/6. So basically I'm going to take 9.6 divided by 2, which gives me 4.8. That's multiplied then by 40.2 plus x, and that equals to 288.96. Now what I need to do is the distributive property. So now I'm going to take 4.8 and multiply it times 40.2, which gives me 192.96 plus 4.8 times x is 4.8x. Now I'm going to have to subtract 192.96 from 288.96. And that gives me 96, so 4.8x equals 96. Now I'm going to divide 96 by 4.8, and that gives me 20. So x equals 20. That means this value right there is 20 in order to give me that area. So again, some of these get a little more complicated with the algebra at times, but just work your way through them. So I'll let you try this one, and I will move on. So again, check your answers with the notes when you're done so that you can make sure you're understanding not just the setup but the math. This one says the height is 5 meters. One base is 3 times as long as the other base. The area is 70 square meters. Find the lengths of the bases of the trapezoid. So I'm going to draw a trapezoid. Doesn't matter if it matches the description. Okay, I know the area is 70 meters squared. I know the height is 5. So I know we have one base and we have the second base. So it tells me that one base is 3 times as long as the other. So if this base is x, then this base is 3 times x. So now I can fill in area equals 1/2 base 1 plus base 2 times my height. So I'll put my area in here, and I'll put in base 1, which is x, plus base 2, which is 3x, times my height of 5. So this gives me 70 equals 1/2 times 4x times 5, because 3x and 1x is 4x. So now I just have numbers to multiply. 1/2 times 4 is 2, and 2 times 5 is 10. Or take 1/2 of 20, and I get 10x equals 70, so x equals 7. So one base is 7, and the other base is 3 times that, so 21.